So the following problem works in a very similar way. Now we're going to map the region outside the unit disk and another disk, which is on the real axis, has a center on the real axis, distance b along the real axis and radius a. We're going to map this white region outside these two disks onto the annulus again, the same annulus as before. So again, if we use a transformation of this form, this circle here will automatically get mapped to this circle here. And as long as we choose that z0, mod z0 is greater than 1, we know that the exterior of this unit circle will get mapped to the interior of this unit circle in the W plane. Okay. Now, this problem is actually very similar to the two eccentric circles, because basically what we want again is that f of okay, we're going to call our z0. Okay. Well, the next thing to say is that again we want the real line gets mapped to the real line. So again we can ensure that by choosing psi equals 0 and z0 is a real number q. So this problem is really identical to the problem of eccentric circles. Basically what we need is that f of a plus b will get mapped to either c or minus c, but essentially the crucial thing is that whatever happens, this point here gets mapped to the opposite point, whether it's this one or this one. So we know that if this gets mapped to c, f of a minus, sorry, b minus a will get mapped to a negative whatever f of b plus a gets mapped to. So we therefore, if we plug all of this in, we'll get exactly the same thing as before. So we end up with, as in the case of the eccentric circles. So as before, we get q plus or minus. So we get the same quadratic as before. If we rearrange the discriminants, so okay, well, 1 plus b squared minus a squared greater than 2b gives us b minus 1 squared is greater than a squared, or b minus 1 is greater than a. So I'm using the same thing as before. This time I've written it as b minus 1 rather than 1 minus b squared. The same thing, end up being the same thing. When I take the square root, this condition here makes sense, because what I'm saying is that b minus 1, actually this distance here, needs to be greater than a, otherwise this disk here will intersect with this disk here. So that makes sense, in order that we get real answers for q, which has to be real. So again, q has to be real. So as before, we got the same quadratic as before. We've got that q plus equals 1 over q minus, and we know that q plus has to be the one greater than 1. Okay, so so again we have the same map. So now we have the map w equals z minus q plus over q plus times z minus 1, and that's our map. And again, we can work out a formula for c if we wish by just taking the modulus of this map applied to substitute in z equals b plus a, and we'll get c.